Hello, welcome to the course of operating systems. I'm Ankush Chaudhary and I'm going to be your guide throughout this course. So, you're watching this video currently on a smart device like a smartphone, tablet, computer, laptop. You know what is common in all those devices? They are all having an operating system. So, to run most of the modern applications, we need an operating system. Interesting. You know, in this world where we are getting more and more connected, we need operating systems to be in more and more devices. And every device has its own needs. You know, like a smartwatch, it will have a little bit of a different kind of an operating system, you know. Or if you're using a computer, it will have a little bit different sort of an operating system. But they all always need an operating system. So we are going to go through the concepts. Why do we need an operating system? What are the different kinds of operating system? What are the architectures of it? All of these things in detail in this course. Do not worry if you're new to this subject and you do not have any idea about what any of those things mean, because I'm going to go through each one of these things, handhold you, and tell you all there is to know about operating systems in this course. So please be awaited and watch all those lectures which I have specially designed for you, and take all those quizzes which will check your knowledge after each of the completion of the module. Also, I will be providing my own made notes on operating systems. So if you want to revise those concepts, you can go through these notes and you know revise them whenever you want. Thank you.
I have divided this course into 5 modules, and you do not have to worry if you do not have any idea about operating system, because this course has been specially designed for absolute beginners, where we will build the foundation and make an understanding about operating systems for you. So let's look at all these modules. Firstly, we have overview of operating system. In this module, we will understand what an operating system is, how it functions, um, what is the need of an operating system in a device, and how it actually helps the user, and a little bit of architecture of a basic operating system. Next, we would look at background and basics in the second module, where we would dip into a little bit of history and evolution of operating systems, what are the different kinds of major operating systems that are into existence, and a little more about the architecture of the operating system. Next is the module 3, processes. Here we will understand what an process in the computer system is and how a process is executed using an operating system. Next, we will look at CPU scheduling. Here we will try to understand what CPU is, how it works, how it engages with processes, and where does the operating system help in all of this, how it helps in scheduling all the processes and all of those things. Finally, we will look at storages and file systems, which are an integral part of operating system, because it helps us storing files in different formats. So many times when we are storing files and things, sometimes we say that it is not compatible or these kinds of things. A little bit of idea of that we would get while going through the final module. Okay, let's start with the module 1. So as we have already discussed, we will be having 5 modules, and one by one we would be going through each and every module, and we would be having quizzes at the end of each module. So guys, that would be the test of knowledge. After each module, we will keep on checking how much we have learned. So let's start with the overview of operating systems. So if you are currently watching this video, you must be watching it on a computer, a tablet, or a smartphone. What all of this have in common? That is that all of them are actually computing devices. Basically, they're all computers. So all modern computers have an operating system or an OS loaded on them, which helps all the other applications to be run on that device. So that is the basic definition of an operating system, that application which is there to interact between the hardware and the other softwares that you want to run on it. So let me ask you this question, that what kind of a device you are currently using. So you might be using a MacBook, you know. They have Mac operating system, which is developed by Apple, of course. Or you might be using a Windows laptop or a desktop. So these could be from any brand like Dell, HP. So many of such computers come preloaded with Windows operating system. Other than this, if you are using a mobile phone, so you would either be using an iPhone or an Android phone. So everyone knows this, that all the iPhones, of course, the software of iPhones is made by Apple, so they would be running iOS. And any other phone, if you're using, most probably it must be having an Android operating system. Okay, so that was a little bit idea about some popular operating systems. Other than this, many people use Ubuntu or some other sorts of desktop operating systems that we will try to get into a little bit later. In mobiles also, if you have used some old phones like BlackBerry phones, or some Windows phones which used to come like the Nokia phones, or in earlier times we used to have Symbian phones. So those are some other uh, operating systems which used to exist. But currently, the most popular operating system in mobile phones are iPhones, which have iOS, and the other phones which have Android operating system on them. And in desktops, we clearly know that the most popular operating systems are Windows and macOS. Uh, Also, if you use any smart devices like smartwatches, they also have an operating system. So, like if you are wearing a Apple Watch, if it would be having WatchOS on it. So similarly, any kind of a computer, if you are having, that would have some sort of an operating system onto it. So let me ask a question to you. What is operating system and why do we need one? So you might not know the answer of this question right now, but we will try to figure out the answer in this module. So to explain all this, I would like to give you an overview using a diagram. So look at this diagram. Here we have computer hardware. This computer hardware, what it is actually. In the middle, you see the computer hardware. So this is basically the hardware which has a processor, some sort of a RAM, some sort of a storage. If you're not familiar with all these terms, basically it's the thing you can touch and feel, you know, like the mobile phone. You can touch in hand, so inside it we have put a lot of technology. So all of that thing is the computer hardware. Now operating system is the software which is sitting on this hardware. Now this software helps us navigate inside the device. Like if you open your smartphone, all these application come. uh, See, you can slide and you can see the time. All these things which you are doing are mostly done in the operating system. Now if I open an application like the YouTube app, that is a application program which sits on the operating system. So YouTube is an application. uh, in short, we call the application as app. So this is the app which sits on the operating system, and most of the time we are working in an application or the app. So like YouTube, or it could be the camera app, or some video playing app. So all these applications which we need to use for them to open and to function, we need a layer, and that layer is known as the operating system. Okay, and you might be seeing in the diagram on the top we have this user is nobody but you yourself. So if you are using a smartphone, let's say, so generally when we have a smartphone we make an id, uh, like I am Ankush, so I will make an id with the name of Ankush. So Ankush would be the user of the smartphone, and he would be using an application like the YouTube application, and that application would be run on the operating system, which would be lying on the computer hardware. So this is the basic overview of how operating system helps the user interact with application which are running on the computer hardware. So let's look at these definitions a little bit. So we would the computer hardware. These are the CPU, memory, input output devices which we connect with our computers. All of these things are hardware which we can feel and touch. Next is system and application programs. So what are system and application programs? These are like YouTube application or browser like Chrome. These are all applications which we run on our device. Next is operating system. It is the layer which helps the application run on the hardware. So this is what we need to understand.
With this file, I have attached all my presentation slides which are being used in this course. So you can just refer to them and go through them if you want to do so.
Hard disk or a storage device on which we could store data. If I talk about it in nowadays, we don't even realize it. We just click a photo and it is saved. But in earlier times, whenever we would run a program, let's say I ran a program in calculator. So like in normal calculator, the when we are done with the calculations, all the memory is lost. So all the previous calculations we did are not stored. So earlier computer were like that. Then the concept of storing the information and data came. We had devices like hard disks on which we could store data. So now when we write a program and we get an output, it could be stored in the storage device, which we can later visit and read through. Like we write a document, we can just read it whenever we want. So if we think about it in nowadays, it seems very bizarre that we do not even have a method of storing data. But earlier computers were more like calculators. I think that is a better way to understand how they used to work. After that, various operating systems came, which were developed by different companies, and some universities also made operating systems where they did research and made these wrote these softwares. So, few very famous operating systems which were written were, one of them was Unix. So Unix was a very famous for its kernels. Kernels are nothing but the kind of the way the computer understands instructions, like if we will give inputs. So the basics of an OS is the kernel system. So those things were very refined. That is why later, like we have these what do you say, these Mac operating systems, they are Unix based only. So the Mac OS is actually Unix based, and other than that, The other very famous operating system, which was written by Bill Gates, um, and it was the DOS operating system, which he wrote for the IBM. So it was popularly known as the PC DOS or IBM DOS, because IBM did not had any sort of rights uh, over the DOS. Microsoft launched their own operating system under the name of MS-DOS, and any company could get a license from Microsoft and put their OS in their computers. So this is a little bit of history about how Windows, which was later made by Microsoft, came into existence, and how the Mac OS, which is currently very popular, came into existence. So DOS was not like today's DOS, or these operating system were not like today's operating system where you have graphical user interface. They were more like you will give a command of, if you want to open a file, there would be a simple command like, uh, if I have a file named Ankush, to open that file there would be some command like open file Ankush. So these sort of simple commands used to be there, and this is not an actual command, I'm just giving an example. So these kinds of commands used to be there. So what we have understanding of operating system is a little bit different uh, from what it used to be. So now most of the work is done through the graphical interface, means you see something on screen, you click it. This way we interface with the computers, so it has changed over time. So the DOS operating system had used to use the FAT file system. Even now, if you are using a Windows machine, you can have drives in FAT file system. And now we have other file system also introduced with the higher capacities and faster read and write speeds have come. Now let's also look at a little bit more about what kind of hardware used to be there, like we were talking about storage. So like earlier computers, like I think you might not have seen this kind of a computer. So this is actually um, a computer made by Radio Shack. Radio Shack also used to make computers at that time. So you can see there are these two drives over here. These are two drives, two floppy disk drives. So one drive would have operating system on that. So if I have to run a program, so that program would be in one floppy disk, and I will add another floppy disk where my files would be stored. So it used to have two floppy disks. So on one we would have the application or the operating system which I want to run, and the another one would have my files written into it. So there did not used to be hard disks. That came into existence later, and initially the hard disks were very expensive, so we used to have these kinds of system where we had two floppy disks. Okay. So let's look at the architecture of computer system in modern times, how it actually looks a little bit. So we have a CPU. CPU is the central processing unit where all the processing of a computer takes place. Then we have disks where all the data is stored. Okay. So if a program or the operating system is installed in the hard disk, so whenever the computer starts, okay, whenever the computer starts, first of all the operating system is loaded. Okay. And if I have to open any application, so all those commands will go to the CPU, and CPU will locate, okay, which file you want to open in the disk. It will search for that file, it will open that file, and that will appear on the screen. Other devices which are connected to the computer, like a printer, if I give a printing command, CPU will get the command, okay, you want to print this document, then it will send the instruction to the printer, and that page would be printed. Okay. So this is how computers work, uh, and you can see underneath we have this memory. So every instruction which we have to send to the CPU, first that goes into memory, and then the CPU reads all the instructions from the memory. So if a file has to be opened, a user would give a command. Okay. we clicked on a file, we want to open that file. So that command would go, uh, then the file would be searched in the hard disk, it would be loaded into the memory, and the CPU would give the command to show that on the screen, and then it would be displayed on the screen. Okay, if you do not have much idea about the hardware of the computer system, I have made this slide particularly for you. So let's look at what these things are. So like I talked about the central processing unit in the last slide. So the CPU is the heart of the computer and the brain of the computer. So everything which needs to be processed is processed in the CPU. But CPU cannot do it by itself. It needs some memory. Okay, so a cache memory is the memory attached with the CPU. It's a very fast memory, but it's very small memory. So whichever files are very frequently used, they would be in the cache memory. Next is the RAM. RAM is the primary memory. So you can think of it like veins. In the body, we have veins which circulates the blood. So RAM is like something which will circulate the blood or take the message from one area to the another. And most of the data which we have to store is stored in hard disk. I think this is very basic definitions which you can understand, okay, if you did not have an idea. And I think most people would know what a computer processor is, what a RAM is, what a hard disk is, but I like to keep things simple and explain them from the very basic level. Okay, and also do not worry if you think something is being missed. You can watch these videos again, um, and after the end of every video I have put a small quiz. Please try to go through that quiz and try to solve all these questions. These are these simple MCQ questions, but when you will do those, it would be like a knowledge check and you will feel confident. Yes, I have grasped these concepts, now I understand what these things were. It's not an exam or something like that, it's just for yourself to check your own knowledge. Okay, so I would be ending this video right now, and the rest part of this module would be covered in the next video. Some popular operating systems. Most of you who are watching these videos on a computer most probably are using Windows operating system, as it is the most popular OS worldwide. If you are using a Dell, HP, Lenovo, or for that matter, most of the company's laptops, they must be a Windows computer. So, as we have had a look in the earlier video, that how Microsoft made this operating system MS-DOS for IBM. So IBM did not had any sort of rights on that OS. So Microsoft launched that OS by themselves in the name of MS-DOS. Later they developed other OSs with the graphical interface also, like the Windows operating system. So now we would first understand a little bit about what a graphical interfaces, and also we will try to understand that what is the need of this licensing in software industry. See, if we have any sort of a product, if we are buying a pen, we would pay the price of that pen and then we will get it. But software, you can just copy it and you can make millions of copy of that software. You do not have to manufacture the OS again and again. So you write the piece of code once and you have that software ready. Now you just can make digital copies of it n number of times. So how to monetize it? So what companies do is, same is the thing with the songs, like songs and movies, they also have the same thing. In the digital medium, the books also have the same thing. So how do we get people to pay for the books if they will just copy the PDFs? So we have a term called as copyright, that who has manufactured the original product has the copyright on it, and if anyone copies that product or material, they have to give them a fees. Okay, so to run Windows operating system, we have to pay a little bit of amount to the Microsoft, and then we can use that operating system. So whatever the price is, like it must be around somewhere around like $100 something like that for the license of the Windows. So this is the model which Windows uses, and they sell their operating system to the customers and we use it. So why I'm telling you this is that we have to understand the model, the business model of the software industry also. Like we are seeing these days that these tech companies, they are making millions of dollars. So how are they making this much amount of money? It is coming from our pockets only. Okay, so I thought this is an important point which we need to cover. That is why I included this in this course. um, Now, I would now let's look at some other operating popular desktop operating systems like macOS. If you are using an Apple device currently, most probably you are using macOS. So this is also another very popular operating system. Initially, when the kernel was written for Unix-based systems, that was later than you know the license of that was taken by various companies, and Apple was one of them, and they uh, developed this modern operating system on that same kernel. So that kernel is same which was there, and now this is the second most popular operating system other than Windows. So, like earlier, we discussed about how companies license their softwares. What Apple does is they do not sell the software separately. If you buy a hardware product from Apple, you get the software bundled with it. So, any Apple user who has bought a MacBook or a Mac desktop computer, they would get the Mac OS pre installed on it, and you are free to use it for life. So you might say, is it free? Actually, it's not free. I would say the cost of the software is inclusive in the device itself. Okay. Um, Now there is I have told you these two models, but actually there is one another model which is being used. Let's look at that. That another model is known as open source model. In open source, what happens is mm, you write the piece of code, and then you um, uh, give that code. So when you sell that to somebody, you will give the source code of that OS also. So like Linux is a very popular open source OS. So when you get that Linux software, like Linux has many distributions, one of the very popular distributions is Ubuntu. So when you get that um, operating system, you get the source code also. So you can make some changes into it, and you can publish your own operating system. Okay, so this is getting a little bit technical, but the thing is, you have to understand the concept why open source came into existence. Some companies thought that these big multinational giant companies are having monopoly over these softwares. So why not we have a community based operating system where everyone contributes and everyone can freely use that operating system? So the concept was good, and in this everyone many developers contribute and make enhances into the system, and then they launch their own operating system. So that is why you see so many different operating system based on Linux, like Mint, Ubuntu, then we have Red Hat, and many such things. And some of these operating systems are actually commercial operating systems which you have to actually pay and get. So open source does not necessarily mean it's free. The concept was to bring on the community. But some of the operating systems in open source community are also paid software. So do not confuse open source with free always. But primarily the concept is to make a community based system where you can contribute and we can have various people working together and distributing the softwares. So it has brought in a new sort of a revolution. But I believe that existence of paid good quality software and services has been um, important part of the industry. So open source also does exist parallelly, and it's a good thing. So another very popular operating system which is open source uh, is Android. Many people don't know it, but Android is an open source operating system. You can have it in any mobile phone, and you can modify it, and you can use it. So while we are talking about mobile operating systems, um, let's look at uh, some of the very popular mobile operating systems, that is iOS and Android. So iOS is uh, developed by uh, Apple for their iPhones, and Android has been acquired by Google, and they develop it for and sell give the license to various other brands. So uh, the basic difference between a desktop operating system and the mobile operating system, initially it was to make the software you know to be feasible to be run on a device which is not that much powerful. But now mobile phones have become very much powerful. And the second challenge to develop an operating system was like, in a computer we have a keyboard, so we can't input using a keyboard in a mobile phone. So how to develop a smart operating system? So various different innovative things were done. Like in earlier days we used to have those Motorola phones, Nokia phones, or Blackberry phones. They used to have a keyboard, so we used to have scrolling functionality to navigate between the menus and other those sorts of things. But when we had first touchscreen phones, we had to reinvent the design, and hence we had the devices, smartphones like uh, iPhones and other Android phones with great innovation and great operating systems being developed for them. Um, so all of the modern operating systems actually have a graphical interface. As I told you, I will explain you what the basic difference between a graphical interface and a non-graphical interface is. So you see, currently I am moving this cursor. So you can see that cursor is moving on the screen. See? So uh, this mouse pointer which I am moving and I click on the screen, this is possible because I have a device like and mouse. Think if we did not had mouse, how would we communicate? We would have to type something on the keyboard, maybe. So um, earlier what we used to do is we used to type in all the commands. I told you this little bit about this in earlier video also. But the main challenge for graphical user interface was not that. See, you can say, okay, we do not have to type in commands. So how will I navigate to a file? That was a big challenge. And all these challenges were resolved with the invention of a smart device known as mouse. Because now we had a medium to uh, you know just scroll things. Things would be listed on the screen. Okay, but how to select those things which are there? If I you the other method could be like, I have arrow keys on the computer, I would use the arrow keys and then use the enter key. That is okay, but that's not that smart. Yeah. If you remember, in the earlier phones we used to do that. So we would scroll and scroll and scroll and select with the OK button. That was like long process for just going and opening a file. But this mouse revolutionized everything, and that is, I believe, the very big innovation which pushed the graphical user interface. And Mac OS and Windows both brought in graphical user interface in early 90s. And then when the touchscreen mobile phone came, so the idea behind the touchscreen was this, that to give you a big display and for you to be able to open all these applications just on the tap of a finger. And I believe this has been a great revolutionary 30 years in the tech industry. Every of those technologies, like we have GPS, we can just send messages to anybody, we can just click photo. uh, all of those things are just lying in our pockets. So all of these great innovations which we are doing, in all of those, a very important piece of software is operating system. So I think this course is a very important course, and everyone should uh, go through this course and try to understand what is the importance of operating system in our lives. Every day we are having an interaction with these kinds of devices. Let's say we are having um, a computer, a mobile phone, a smartwatch. Every of those has an operating system on that. Okay, guys. Now I would be okay, I would be logging off from this video. Please go through the next module. There we would just get to know a lot of more things about operating systems. Thank you.
Module 3, Processes. So, what we would look in this module is, first of all, we will understand what is meant by an process in a computer. So let's look at the basic definition. When a program is being executed, like let's say a file has to be stored in the computer. So this is a program which needs to be executed. This, in terms of computer language, is known as a process. So when we are dealing with the computers, whenever something has to be done, let's say we clicked a photo. So when we are clicking it, it is a process. When we open an app, it is a process. When we delete a file, it is a process. So everything which happens inside a computer is actually a process. So lots of processes are being done on a computer simultaneously. Okay. There is a little more bit of a theory if you want to understand that would be provided with the notes. But the basic understanding you need to have is that whatever is happening on a computer or a mobile phone device is actually a process. Okay, let's see how a process is actually executed. So for that we have to understand that if any process has to be executed, that would be executed on a microprocessor. Micro means small and processor means the hardware on which the process runs. Okay, in general terms we also call it a CPU or central processing unit. Initially with the CPUs which were made was single core. That means they had just one core. One core means at a time we can execute only one process. Now with advancement in technology, we have CPUs which are dual core or quad core, which means that simultaneously we can run 2 or 4 or more programs. So more cores means more programs could be run simultaneously so that the computer can do multitasking. Okay, so in today's time you will not find a device with less than 2 CPU cores at all. Okay, so the basic thing is you can understand it like as a window. When we go to a box office and we have to book tickets, let's say for the movie. So if we have only one box office, then only one person would be able to get a ticket at a time. If we have 2 box offices, then there would be 2 queues, and simultaneously 2 people can buy tickets. Okay, now some people take a lot of time choosing which movie they want to watch. So there could be processes which take long time to execute, and there are processes which take less time to execute. So someone who has already decided which movie they want to watch, which row they want to sit in, how many tickets they want, they will quickly do it. But some people will take longer time. So that is how there are small processes, there are long processes. Okay, so just think of it like we have a box office and we have people coming in queues. So processes are also kept in queues, like people are standing outside the box office, and we keep on selling tickets. So each process keeps on getting executed and new process keeps on coming. Okay, let's move on. Now I have explained a basic architecture of a CPU. Now how it happens is like there would be an input device, like I typed something on the keyboard. So those instruction, like I press the space key, so the space key instruction will get inside. Okay, um, now the CPU can read from the memory and it can give instructions to the memory again back. Okay, so let's say I press the space bar, so that instruction got into the through the memory into the central processing unit, and then it checked what the instruction is. Okay, it is a space bar, so it will give a command to give a space in the words. Okay, then that would be executed, and on the output device, let's say your monitor, that would be executed. Another example we can take is like I am opening a file, so I'm double clicking on the computer. So when I double click, uh, uh, that instruction would get inside the CPU, and then CPU will say, okay, we need to locate this file. Then it will start searching for that file. Okay, so there would be a map of all the files, like we have index in a dictionary. It will search whenever it finds a file, it will open that file, and then it would be shown on the output device. Okay, so now how does memory come into picture here? So if any instruction set is there, it would be written in the memory, because CPU cannot handle a lot of information at a time. It just takes the information which is necessary at the time, and rest all important information which might be required later on are written in the memory. So let's say if a very big program is there, we are supposed to run it. Let's say I have to open the Photoshop app, or let's say Chrome browser. That's a easier example. So if I have to open the Chrome browser, that Chrome browser would be loaded in the memory. Okay, so any instruction I will give on the computer to, like, if I'm scrolling my mouse on a web page, okay, those instructions would be taken from the input device into the CPU, and then it would be executed and would be given out on the output device. But where is all the data and information of the Chrome stored? That would be stored in the memory unit. When I close the Chrome browser, this would be removed from the memory unit. Why? Because we have limited memory. Generally in our computers we have 8 GB or 16 GB of memory, and we do not want to fill it. If anything extra needs to be stored, we will store it in the hard disk or the SSD of the computer. Okay, so that is also instruction we will give save, like we have that save as command. So whenever we save a file, it is saved in the storage unit, and while we are working on something that would be currently working in something, that would be in the memory only. Okay, so whenever a application is opened, it is first loaded in the memory unit. Okay, let's continue later after this in the next video. In this module, we would be looking at CPU scheduling. So CPU scheduling is a very important task, because as we have discussed that a computer has one processor, whether it is your mobile or your computer or desktop. So there are some tasks which are priority tasks. There are some tasks which will take longer time to run. There are different sorts of tasks. So which task to perform first, which to later, because we have limited resources. We can take example of ourselves. Like, I want to do everything. I want to exercise, I want to eat, I want to dance, I want to listen to music, I want to do office work. But can I do all these things simultaneously? No, I need to have a schedule. I will wake up in the morning at a particular time. I will do my brush my teeth and do other routine activities which are necessary. Similarly, computer will do some necessary activities, and then according to the tasks of the day, we will perform. Like if it is a Sunday, I might go for some outing or do some other special activity. If it is a working day, I will go to the office, and in office there could be different kinds of tasks given to me. I might in the dinner I might be preparing the dinner myself, or I might go out and have dinner. Similarly, different tasks could be thrown at the computer, and according to them, the it need to be scheduled, because you cannot do everything simultaneously. Okay, so how does a computer decides which task to do first? And obviously we are living in a time where we need to do a lot of things simultaneously, so computers are smart and they can do multitasking. How does this all happen? Let's have a look. So first, let's get through this basic definition. The switching of a process from the existing process to a new process, one when a process is complete or a more priority task has come. So when will I move from one process to another? Either my task is over, like if I am done with brushing my teeth, I can go forward and have breakfast. Or sometimes when a more priority task has come, let's say I was watching a movie, but suddenly I get a call, and someone says, did you send that mail? And that was an important mail. I will pause that movie and send that mail first. Okay, similarly, in computer also we have priority lists. Okay, according to which we will prioritize which task to do first and which to do later. Okay, now let's have a look at the uh, little bit of an architecture how this scheduling goes on inside the computer. Let's take an example of a single core system, and I will also explain you what is a single core system afterwards. First, just let's have a brief understanding. Okay, we have memory and input outputs over here. So let's say some input has come. Okay, we have typed something or we have clicked something on the screen, and after that the input has come, it goes through the bus is like a lane, you know like we like water runs through pipes. So bus is like those pipes which carries the water. Similarly, here the bus carries the data. Okay, it's nothing else. So from input, the data would be carried, and that data would go into the from input. The data would be carried using the bus to the see this here. This cache and registers. They are all part of the CPU. So cache is a kind of a memory which is inside the CPU. So what cache does is it stores those kinds of files which are very oftenly used, so that it does not have to bring that information again and again from the memory. So cache is a very fast and a small memory. So like you must have heard key like that, remove all the cache, and your computer is getting very slow. So what cache does is, if a file which is very frequently used, it will store those files. Generally the cache memory is only of some kilobytes, like 128 kilobyte or 512 kilobyte, or sometimes max to max it would be 4 megabytes or something like that. So this cache memory will store the frequently used files over here. And then here we have the CPU is a collection of transistors. So it does electronic things. If you do not have much idea about how CPU works, just think it has some electronic signals which comes out and goes, and some calculations happens, and our program is run. Okay, so this is the basic architecture. Now why I showed you this diagram is to understand like that some input will come, it will get inside the processor, it will get processed, and the output would be given out. Okay, but like this, a CPU can only perform one task at a time. So it cannot perform a lot of tasks simultaneously. To overcome this, we came up with the concept of using multiple CPUs. You will say my computer does not have multiple CPUs, but actually it does. How? A general computer which we buy or a mobile phone which we buy has a multi-core CPU. What it means is, inside the single CPU we actually have cores. Cores are nothing but CPUs themselves. Okay, they are processors. So when we have two processors together combined into one CPU, it is known as a dual core. If we have four CPUs combined into one CPU, then it is a quad core. How it helps? It helps like one task would be run on the first CPU core, and if some other task comes, it would be performed on the second CPU. This way, if one task is being performed on the first CPU and the second task is performed on the second CPU, so we can run more than one program simultaneously. So all modern computers have at least 2 cores. Some have 4 and 8 cores also. Most of the modern smartphones which we have minimum of 4 cores, and most of them have 8 cores. So how it helps? Like some very heavy program is running on the core number 1. It is continuously running for a lot of time. So, and what the second core will do, it will prioritize the small tasks. Okay, whichever small task is coming, it will quickly process them and keep on doing all those small tasks. So we understood it uh, in a lot, and then we thought that how can we make it better. So we came up with various other concepts which we will discuss briefly. Okay, So let's look over this slide. See, this is our smartphone, and while we think it is not a process, but while we are swapping between the CPUs, so sorry, we are swiping between the apps, that is also a process. In a computer, when we are working, we have all these windows open. But do you know, when these all windows are open, actually we are not working on four different applications. uh, the applications might seem that four applications are being run simultaneously, but if I have only a dual core system, that might not be the reality. Maybe uh, the priority task on which would be the priority task, the task in which I am typing. If I have this window open and I am clicking over here, let's say I'm clicking on notifications, so this is the priority task which which the user is working on, and that is the process which the processor will pick. The apps which are in the background, like this applications app or this some graph application, these will be I'm seeing them on the screen, but in reality they would not be getting processed on the processor. Okay, so this is how we decide which is a priority task. The task which is in the front I'm typing on is always the priority task. Okay, when I switch and click on this window, this second one will become the priority task. Okay, this is how they decide. That is why to have more and more cores help, because we can have multiple tasks being run simultaneously. So as discussed, you must have an understanding now that how multiple cores can help. One another advantage of having multiple cores is that we can increase the efficiency of the processors. As mobile phones required more efficient processors, that is that on batteries we cannot run desktop grade processors, so we needed to innovate. So the answer was ARM, and ARM was we were developing ARM, and we were increasing cores rather than having too much of energy consuming cores. We increased the cores so that more cores, more performance would be there. We will divide the big task into small tasks. Later, we were able to achieve so much of efficient cores in this last decade that we had uh, developed a new way where we would divide the cores into efficiency core and the performance cores. So how this concept would work is like, let's have a look at this diagram of the Apple A14 chip. So we have a 6-core CPU over here. There would be 4 efficiency cores and 2 high performance cores. What we would do here is, in these two efficiency in these two performance cores, they would be able to run very big tasks. Okay, so like if you're doing gaming or some extreme task which require a lot of CPU performance, these high performance cores would be able to take it to the extreme limits. But if there is some small process, just opening of some light application, then the efficiency cores will be used. Okay, so when our mobile is sitting idle, at that time also a lot of processing is going on. So at that time only the efficiency cores are working and high performance cores are not working, so that it can retain more and more battery. So on minimum battery, we can run the mobile for longer and longer period of times. Okay, so we come up with this very new architecture. Also with this emerging architectures, what we have done is, like, we have special cores, like you can see in this diagram. See, only 6 core CPU cores are there, but this uh, you know processor is very big. This is actually a complete device on a chip. Okay, it has a lot of other sensors. We have image processing unit, which is specially designed when we are using the camera. We might think that we are just clicking a picture, but to process this picture requires actually a lot of performance. The cameras in our mobile phones, which is like a 12 megapixel camera, which actually needs to process this 12 million pixels at a time. That requires a lot of computation. So we have a special computation unit for that. Similarly, we have GPUs. GPU is when we are using some graphic intense application, that time these GPU cores will kick in laptops and desktops. Also we have these GPUs which do all these graphics intense tasks like gaming or using some application like Photoshop. And if you are doing too much of graphics intense tasks, then a lot of time we put a dedicated graphics card inside the computer. Okay, all those things and dealing of these different hardware, all is done by the operating system only. Okay, nowadays the modern processors which are coming also have the neural engine, which help in training and gathering information, so that the device can learn a lot of things, use AI technology, uh, and these cores are specially designed for doing the AI work. So this way, the mobile technology has come a lot of way from it used to be in 70s or 80s. And they have come so much far away, like in the recent time, uh, we have started to use these mobile processors which were actually designed for mobile phones now in desktops. Like the latest Apple computers are coming with the M1 chips, which are actually more powerful mobile chips now put into laptops and desktops. So the basic difference is that these cores are little bit, you know, more designed for more performance. So see, here we had a 6 core architecture for mobiles in A14, but in M1 we have put a 8 core architecture with 4 performance and 4 efficiency cores. So now our computers can do a lot more processing than they earlier could use. So these processors are known as ARM based processors. The quality of ARM is what? They use less power and give more efficiency. Earlier we used to have Intel processors. Still, most of the computers used around the world are Intel processors. The biggest drawback of Intel processors, which has come in recent years, is that they use a lot more energy to do the same task. That is why now these computers are giving a lot more battery life. Our mobile phone lasts for a complete day, but our laptops just last for 5 6 hours. So we need to say, and I think more innovation is coming this way in the upcoming times, and we will see more faster efficiency in processing and all those. And I would be doing a course on processors also soon. So keep waiting for that. Soon that would be out also. And please do take all these questionnaires which I have made after every module to test how much knowledge you have gained. Storage and file system. So in this module, we are going to talk about storage and file system of our computers. Like the operating system manages all the different input-output devices in our computer, it also manages the storage in our computers. To understand what a storage in a computer is, we can take an example of real world. Let's say I have to gather some information and make a record of it. What would I do? I would get a diary and I would write all the information in it. and then I will keep the diary in my bookshelf or in a drawer. Similarly, in a computer, we might not realize it, but on an everyday basis, what we do is we open a Word document, we make a document and save it, or we click a photo and it is automatically saved in the photos folder. So when all these things are getting stored, they are actually getting stored somewhere. Like when I wrote the information in the diary, I kept the diary in the drawer. So the storage location of that information is my drawer, which is inside the diary, which is a physical entity. Similarly, in a computer, when we store data, it is stored in a digital format, but the digital format obviously has a location where it is stored. It is mostly stored on a storage device, which may be a hard disk or a SSD, which is inside our computer. Okay, so whenever I click on the icon of that file, or I tap on that photo, that file opens up from the storage. So the processor quickly goes and searches for that file inside the storage and opens it up on our screen. Or if it is audio file, it will give a output in form of the audio, or whatever the format of the file is, it will give a suitable output. So it's basically a basic idea of how storage works. Like we have storage when I was storing a diary in my drawer, or when we are storing let's say fridge in our food in our fridge. That is another example of storing something in a place. So now let's look at the way the files are stored in the computer. Okay, so let's see a little bit more about storage. There are two kinds of memory devices. Now you might ask what a memory is. In the computer, when data is stored, we call it that the data is stored in the memory. Like in medical terms, we say, I cannot recall it in my memory. Memory is the data stored in our brain. Similarly, the computer's data is stored in the memory of the computer. So basically, we have two kinds of memory. One is a DRAM, or fast memory, which is very frequently accessible by the processor, but because it is expensive, we have less of it. And another kind of a memory we have is a storage device like a SSD or a hard disk, which is comparatively cheaper but can store a large amount of files in it. So you might ask, what is the speed here of, what is the relevance of the speed here? So to understand it, you can understand it like this. The RAM is like the refrigerator of my home. Okay, so anything I want, I can quickly go to my refrigerator and I can get from there. But my refrigerator is a very small space, so I can only put a little amount of fruits or a little amount of vegetables in it, or some jams or whatever. But if let's say I have to keep food for like 1 year, 2 year, 10 years, can I put 10 years of food in one refrigerator? No. To store more data, we need big storage units. So it is like a grocery store of our supermarket. Let's not take that example. It's like a big storage unit, okay, where we can store a lot more food, lot more grains. These days we do not use a lot of storage because we have supermarkets available to us very nearby. That analogy will come in useful later on. Okay, so we have understood how storage works. It's a space where I keep the digital information inside my device, my computer, or my mobile phone. Okay, so let's see how memory is a little bit different from storage. So like if you're having a mobile phone, like let's say if you're having an iPhone, it will have 3 or 4 GB of memory only, but it will have storage like 64 GB of storage or 128 GB of storage where you can store all these images. Okay. um, Whereas in a laptop also similarly, generally we have 8 or 16 GB of memory in our computer, and rest is the storage. So all my files, all my videos, movies, photos are stored in the storage, and in the memory only the current file. Let's say currently if I'm watching a movie, so only a little bit part of that movie would be in the memory. Okay. If an application is being run in my system, that application would be in the memory. Rest all things will not be there in the memory. Okay. My OS, all of my OS which I am running, the OS will take up a little bit of memory when the computer boots up. Okay. So memory is only accessible when the computer boots up, but storage is a more permanent kind of a memory where the data which we have put will be there when the computer is shut down also, but it is accessible only when the computer turns on. Okay. So this is another point which differentiates a memory and a storage. With If you have been here and working on different sorts of devices for a long time, you must have seen different kinds of storage devices. Like earlier we used to have floppy disks, we used to have CDs, flash drives or memory cards. So these are all different kinds of portable memory devices we used to have. So if want to transfer some data and keep it somewhere else, stored in a physical format, we can store in these things and we can keep them in our shelves or drawers, or we can give it to someone else. So they used to be very handy in past times, but with changing times, memory and storage, we have new different options of sharing data and keeping them stored. So let me ask you this one question. Have any one of you ever seen this message come on your mobile device? Storage almost full. So this is a very common thing which happens in our mobile phones. So companies these days do not give a lot of storage option in mobile phones. Rather, they are pushing the customers to use the cloud services. And what are these cloud services? So what they do is that in our mobile we only have a limited storage. Unlike earlier we used to have huge hard disks, but these days mobiles have very fast accessible storage, but it is very less in amount, like 64 GB or 128 GB. We are clipping big pictures which are like 5 MB each. So a 5 MB of a picture, if I click 10 pictures a day, my phone would be full in few days. If I record a few videos, my phone would be filled within a week. So what do I do? So we have come up with a solution, that is the use of cloud storage. Now let's see what cloud storage is. Rather than having the storage built inside the devices, we have some storage in our devices, but there are huge data centers where huge capacities of hard disks and SSDs are installed, and using the internet we can access that storage. So whenever we want whenever our mobile gets full, we can keep our files over the cloud, that is at a remote place, which is accessible by us using our email ID. So we were discussing the benefits of cloud storage. How it helps is like it also gives us a backup. Let's say our phone gets lost, but all my data is stored remotely on a server. So if I get a new device, I can get all my data onto the new device very quickly. Another benefit of the cloud storage is that I can have data being accessed from anywhere. Let's say I have a mobile phone, I have a computer, I have a tablet. So if I have clicked photos from my mobile phone and the data is being synchronized with the cloud storage on the remote servers, what I can do is I can open my tablet and show the pictures to my friends and family, and we can share information and data more easily than ever before. You see, all these streaming services, how they work, they have their data, their movies, videos being um, so fireworks are going in the background, sorry for that. So what happens is that all those media content of Netflix or YouTube is put on these servers which are highly available. What that means is that they are connected to very fast internet, and if we have a good internet connection ourselves, we can watch that movie seamlessly in HD or high definition qualities without uh, them getting stuck. Like you're watching this video right now, you have, if you have a good connection, I don't think you might be having any problem, and you would be able to see my videos seamlessly, like if it is being played locally. So we have come a long way in computer technologies in the past few years, and cloud storage is the next big thing. Now, in the coming times, I think that storage would completely be gone from the mobiles, and all the data would always be stored in cloud, and we would be just directly accessing it through the cloud on our mobile phone. Let's wait and see when and how if it happens. So, major cloud storage providers. If you are using an iPhone or a Mac, you must be familiar with iCloud. So if I make a Apple ID, I always get a 5 GB of iClouds free, and after that it is chargeable. Similarly, Google Drive is a very popular option. Most of us who are using Android devices, and even if we are not, if we have a Google account, we get a 15 GB of Google Drive storage free. Similarly, we have OneDrive, which is a very popular cloud service by I think Microsoft has that. And then we have Dropbox. Dropbox, I think it was the first platform which became very popular, which gave that that if you have a lot of data but you do not have a lot of storage, just drop it in the cloud space, and whenever you need it again, you can just get it. So very large files which we did not had space to keep locally, we would just Dropbox it. So that was a thing a few years ago. Still Dropbox is very popular, many people still use it. It's a very nice service. So these are, I think, the famous cloud storage providers. Now you must know that there is a cloud computing also. That's a different term, which is for the computing which is done remotely. It is more technical thing, which like AWS provides, like by Amazon, or we have GCP, or we have Azure Cloud by Microsoft. So on that also you can learn about it also. I think there would be a course coming soon on that by me. But meanwhile, we are supposed to know what cloud storage is. And now all these big players need to have that fluency, of data. If I am opening a photograph and it is taking a little bit of time to load, see, that is the lag which we are trying to avoid. And I think very, very good processing equipments are going to come very soon. So let's wait and watch for that. Now, the final thing in this module we are going to touch on is the file system. Now, what a file system is. You see, earlier I talked about the storage, and in storage what happens is, if it's like a, you can think of it like an almirah, or you can think of your refrigerator. In your refrigerator there are different shelves, and in these shelves we can put containers. Inside different containers we can have different vegetables, fruits, pies, different things categorized. But what if I just do not have any segregation inside the refrigerator, and I throw all the vegetables in, then it would be very difficult for us to take out vegetables, uh, and it becomes even more difficult in a computer if we do not segregate them, because data is kept in a very different way. So it's like if we have grains, different grains, let's say you have maize, we have barley, we have wheat, and if we mix them, can we segregate them? Can we take out the kind of data we want to take? We cannot. So segregation in computers of data is like that. So that is why we need to have file systems. What file systems does is it categorizes data. It knows where a file begins, where a file ends, so two files don't get mixed. Now, if you do not, you don't have much idea about computer science, you might be thinking, how can files get mixed? But think of it like we have loose papers. Okay, on loose papers we are putting up data, and we have made files of these papers now. Okay, now let's say if all of these files get jumbled and all the papers get mixed, so we will not know which pages of which file. Similarly is the thing with the computers. If we do not have a proper file system, this will happen. So we need to have file systems in it, which stores data in a logical compartments, and it has metadata of data. What is metadata? Metadata means data of data, like the information like how big the file is, what the name of the file is, where the file begins, where the file ends. These kind of information about the file or the data itself is known as metadata. Okay, so you might be hearing these days a lot in social media, like they are not they are saying they are not taking our data, but they are taking the metadata. So metadata gives a lot of information about something, and that is very useful in identifying what the data is, what kind of data is. mm, just by the looking at the name of the file, we can tell if it is an image or a video. In computers, uh, if we store a file, normally we might not know it, but if you go in the settings, you can check the extension of that file. What it does is there would be something written after the dot, like dot img, dot png, or dot mov. So these are all different short forms for different formats, which tells what kind of a file this is. And this is also a kind of metadata, which tells us, like if a file is there which has an extension of .png, that means it is an image file, and the OS will come to know, okay, it is an image file with this particular extension. That means it would be opened by a photo app, so it will directly try to open it using the photo app only. If the wrong extension is there, the operating system will try to open it with the extension which is given. So let's say it is a music file, but the extension is given .png. So it will keep on trying opening it with the photo app, but it will not open and give a error because the format of the file does not match. So the metadata is very important in identifying what kind of file it is. Okay, uh, so in different operating systems we have different kinds of file systems. So what file system is? The way the files would be organized. Okay, and I also told you like what metadata is, and how it stores the size of the file, and how the extension helps us identify what kind of application it will be able to open that particular file. So these information is also stored. Okay, so like we have popularly we have these three operating systems: the Microsoft Windows, the Mac OS X, the Linux operating system, and all of them have their own file systems. Similarly, mobile operating systems like iOS and Google Android have their own file systems. Okay, so let's look at the popular file systems. FAT or FAT is a very popular, um, what do you say, file system in Microsoft Windows. That is
file allocation table. Then we have GFS, global file system, that is used by most Linux OSs. Okay, these OS have various other file systems also, but I am talking about the very popular ones to identify easily. Then we have uh, HFS, hierarchical file system in Mac operating system. And then we have UDF, or universal disk format, which is designed for all the DVDs. So all the DVDs have this kind of file system on them. So if we store files in them, this is how they will make a table. They will make a table, or which number of bit what file is kept. It is like, you can understand it like a index system, like we have index in the beginning of a book. So file system has a index. So what it does is it tells you on which page number which file is there, where it ends, where it starts. So this kinds of information is stored using the file system. So I think we have covered all the five modules, and after this, please go through the questions which I'm giving to check your knowledge. And then please also do watch the final conclusive video, where we'll have a comprehensive look at all of what we have learned up till now. Thank you for participating in this course, and please tell me if we can have more improvements, and what things you liked about this course and what things you did not like about this course. I'm very open to suggestions, and I would love to hear your reviews and feedback about this course. Thank you. You have reached the end of this course. So please let me know how your experience was about this course. So I had created this course as a very brief introduction to operating system for people who do not have much idea about what is an operating system, what are processes, how this scheduling and all these algorithms work. So a very brief knowledge was being transmitted to you guys. And do let me know about how your experience was in this course. I will try to improve things and maybe even include more lectures so as to make this course more engageful and exciteful. Thank you once again. Please do share your feedback. It is very important for us to be able to serve you better in future.